Okay, so
I don't need them.
on here, children. Okay, so now what we're doing today is we're doing speed versus time graph, okay? Now, as you can tell before, we had different axes, right? Different things on the X and the Y than we will have this time. So this time what we have is we have speed, and I know you have your ISM book and you're ready to go. And you have time. And the first one that you see is a straight line. Okay? So when you see speed and time, it says speed time graph looks much like a distance time graph because we read the labels. Time is plotted in the X, speed is plotted in the Y. A straight horizontal line on a speed time graph means that the speed is constant. It is not changing over time. Straight line does not mean that the object is not moving. The object was not moving in what type of graph?
Distance.
Distance time, because they wasn't moving distance at all. I'm going to tell you that when you have your test tomorrow, some of you are not going to look at the axis that you're doing, right, guys? And then you're going to forget what that means because it means differently for different types of graphs. Okay? Question, ma'am. So what I've asked you to do is on the notes for today, you can add it there, you can put it on a page, you can put it on the page you put it before. I don't care, just put it in your notes. Because what we're going to do is we're going to do the same thing as we did yesterday. We're going to draw a map that's going to show all of them. Okay? And you're just going to keep adding to it so you'll have it in your notes. Because you're going to give me this. Good? Okay. All right. So that has to go along with that. So if we're doing this, what does this graph mean?
It's constantly going to think.
Constant speed, right?
Yeah.
All right. So if we want constant speed, it's going to go straight across. Now we have one that looks like that. Now, on our last graph, what did that mean?
It was moving.
Constant, right? You're going a distance and you're going at the same speed. Does this mean the same thing?
No.
Okay. So
It's an
this one
increasing
says
speed.
a graph showing an increasing speed. That means it's accelerating. Now, I know most of you know what acceleration is because you know how to go fast.
It's the derivative of speed.
All right. I know you push the gas pedal and you accelerate. You know what acceleration is.
The derivative of speed.
Oh, we know what acceleration is.
Okay. The next one shows a one that is going from here to here. On our other graph, what did that mean?
You were returning to.
Returning somewhere, right?
Yes, sir.
What does this mean?
You're decelerating.
That's the brake, right? You know that little pedal that's to the left of the one on the right hand side
No, that was hard.
that you push occasionally?
That was
Okay.
hard to find.
Yeah, I know. Especially on cruise control, because mine's on my, you know.
I don't have cruise control.
Oh, I'm sorry.
Okay. Not everybody lives with that.
So,
That's
here
what
we
I'm saying.
are in the mode of speed. We're talking constant acceleration. We're talking about deceleration and acceleration, right? Or acceleration. So far, what do you have? What kind of picture? Right now, we've got this. All right, let's go to the right. Right here to the right. So here, we also have, again, our little beautiful little thing like this, right? So what are we trying to do when you see one with a solid line and a dotted line?
Compare. I don't know.
Comparing,
Oh,
yes.
right.
Okay, so we're looking to see for this one, what does that mean?
Which one's accelerating quicker?
They're going faster. One's going faster than the other, right?
Yeah.
We're good? Huh?
Are they racing?
Oh, yeah, they're racing.
That's crazy.
Yeah, I know it's crazy. It happens all the
They gonna
time.
get a ticket.
So here's our graph, okay? So now let's draw the summary graph that we have in here. So our summary graph. No, sir. Don't think so. Okay, so we have this, and this. Draw that on your graph. So you have my graph, and you have this one. We have speed on the side, and we have time down here, right?
Yep.
So this is steadily accelerated. And then we have a steady speed. I love these words they have. We have gradual acceleration. And then we have steady deceleration. Okay. And we've got everything set.
Is there an original graph to this?